Nuclear chemistry, day 2. Aim, how do we balance nuclear reactions while separating particle emissions? Well, on nuclear chem day 1, what we did was we looked at various tables that helped us answer these questions. We looked at tables N and table O. So let's look at the first question over here, okay? The first question says here, which nuclear equation represents a natural transmutation? Well, guys, we learned natural transmutation is when you have one particle on the left producing two particles on the right. What's it called when you have two particles on the left and two particles on the right? Well, if you have 2 and 2, that is called artificial transmutation. What about the second one? How many particles on the left here? 2, good. How many particles on the right here? 2, artificial. The third one, 2 on the left, 2 on the right. So these 3 are all artificial. The last one, which has 1 on the left, 2 on the right, is natural. All right, so do right now the second question yourself. I'll give you time right now. Just hit pause and answer which equation represents positron decay. Hint, go to table O. I don't know why I just did that. Okay. Go to table O. All right. So that's your hint. Go to table O, guys. All right, we're back. 0, -1e. Well, we learned that is a beta particle. 4, 2he. We learned that was an alpha particle. Again, guys, table O. When you have 2 on the left, 2 on the right, that's not natural, that's artificial. So that cannot be the answer. Here we go. When I see 0 + 1e on table O, that tells me that this is a positron decay. Okay, again, beta 0, -1e on table O, 4, 2he is alpha on table O, 0 + 1e on table O shows that it is positron decay. Let's move on. Balance of nuclear reactions. All right, guys, you've done this already in the last one. Let's do it quickly here. First one says 9 + 4 gives me 13. So we need 13 on the right as well. 1 + what gives me 13? Well, 1 + 12. 4 + 2 gives me 6. 0 + what gives me 6? That's right, 6. And what tells me the element? Well, according to the periodic table, carbon is the element because atomic number 6. Remember, guys, the atomic number is what tells you the element, not the mass. All right. Quick recap. We just said when you have 2 on the left and 2 on the right, what is that? Natural or artificial? That's right, artificial. Okay. Let's do the second one here. Second one here, the mass 236 on the left. Well, 236 + what gives me 236? 0. 92 is on the left. 93 + what's 92? 93 - 1. We'll go to table E. 0 to -1e, that is, I don't know why the computer keeps doing that, I apologize. Okay, 0 + 1e, all right. Okay, so that's 0 - 1e, that represents that over there. Next, 14 + 4 is 18. 0 + what is 18? That's right, 18. 7 + 2 is 9. 1 + what gives me 9? 8. Atomic number 8, guys, tells you that it is a quantitative periodic table. That is oxygen. All right. Again, 2 on the left, 2 on the right. That is artificial. This is natural because of the fact you have 1 on the left, 2 on the right. So 198, 198, that's 0. 79 is the atomic number on the left. 80 + what's 79? -1. According to table O, that's 0, -1e. That is a beta decay. Beta decay. I know, my handwriting's terrible. Fine. All right, let's move on. Okay, here we go. Next slide here. Let's go over separating particle emissions. Well, guys, if you notice over here, this looks more like a magnet to me. I have a positive end and I have a negative end. Okay? And here are radioactive particles. They're all found on table N, all right, or O. So radioactive particles like to bend towards charges that are opposite. So guys, which particle would bend towards the positive end? A positive or a negative? Well, opposites attract, so a negative. So on table O, a negative charge is this guy, beta. Beta would bend towards there, because here's beta. Oh, go back. Okay, it's beta. Who would bend towards the negative end? Well, a positive charge, right? So a positive charge is this guy, alpha. If you go to table O, alpha says 4,2He. Well, the 2 tells me the charge is plus 2. Now, which guy on table O actually goes right through because it has no mass or no charge? This guy right here, gamma. If you look up the symbol on table O, it says 0, 0 with the Greek letter gamma symbol. This tells me I have no mass, most importantly, no charge. So gamma goes right through because gamma has no charge, so it's not going to bend towards a positive and negative. Very simple, guys. Positive, beta, which is negative, will go towards a positive. Alpha particle, which is 4,2He, which is positive 2, will go towards a negative, while the gamma goes straight through because gamma has no charge. Okay, very simple. With that knowledge in hand, I'd like you to answer this Regents question over here, please. Which type of emanation is represented by the arrow labeled 2? So look at the 2. Well, 1, if you notice over here, guys, 1 goes to what side here? Well, this is the positive side. So which particle bends towards the positive? Well, opposites attract, right? So that would be the negative beta would go towards 1. Who goes towards 3? The negative end. Well, correct. That would be the positive alpha. Good. And who goes straight down the middle? Which guy here doesn't have a mass or charge we said before? The symbol is 00G. I'm sorry, gamma for Greek letter. Well, charge 0, that is a gamma ray. A gamma would simply go right through. Okay? Let's move on. This is a funny little video about cockroaches, about why they are the supreme insects. Now look at this picture, this diagram over here, guys. If you notice, alpha particle gets stopped by a simple sheet of paper. You notice that? While the beta particle gets stopped by a pretty thick aluminum, okay, piece of aluminum. While gamma rays, which is, if you notice, looks like a little wavelength, as it is, gamma rays are the most dangerous of the rays. And since they're so dangerous and they have no mass or charge, they can pretty much go through everything, except for which metal over here is stopping it, if it's thick enough. That's right, lead. Lead is thick enough, guys, where lead, because look at lead here, you see how the gamma rays stop right there, because this is a very, very thick piece of lead here. So what can we say from this? Well, we can say that alpha rays, since they're stopped by the paper, okay, paper stops it, that's pretty weak. While beta is stopped over here by aluminum, okay? That's moderate strength. While gamma goes straight right through the alpha and beta and gets stopped at gamma, gammas would be the strongest of the 3, all right? So here's a Regents question below. I'd like you to take a moment to please do that question. Now hit pause on your computer and iPad and do the question right now. Okay, we're back. Which list of nuclear emissions is arranged from greatest to least penetrating power? So guys, what did we say before? Which particle went straight through the paper, the aluminum, but stopped at the lead? That's right, that was gamma. Gamma was the strongest, right? Then came beta. Beta, if you remember, was stopped at the aluminum. And then came alpha. Alpha was the weakest. That was stopped by a sheet of paper. So choice C would be your answer, okay? Now, if the question said from least to greatest, then that would be the opposite. Then it would be choice A. Okay, because alpha is the weakest and beta is the middle, gamma is the strongest. Okay, let's move on. This is a pretty easy lesson here. All right, let's move on. Table O. So what did we say before, guys? This is the mass is 4 of an alpha. The charge is 2 or plus 2. Good. So what did we say before? If you notice, it went straight through. It was stopped basically at the paper, right? So if it stops at paper, you think it's the most or the least damaging of the three? Well, that would be the least damaging of the three. By the way, this is the original. You guys don't notice, but because you're young, that's the original hunk played by Lou Ferrigno. He was like a 4-time Mr. Olympian champion bodybuilder. Okay, moving on. Beta. Beta particles over here have a mass of 0, a charge of negative. Because remember, that's the E. Guys, beta particles are electrons. If you notice, the beta particle was stopped where? That's right. The beta particle was stopped at the aluminum. That has what's called moderate damage. While gamma, which has no mass and no charge, or no mass. Okay. Anyway, gamma has what's called the greatest damage. Because it has a no mass and no charge. It's a wavelength, guys, a wavelength. Similar to gamma rays which come from the sun, a gamma burst ray. Okay, let's move on. I have a cool little thing you can watch the video by Fukushima, which is the plant that blew up in Japan after the earthquake and tsunami, and a couple other things here. And that's it. All right, guys.